I'm your EOT educator, Nishi. We saw that the elements cannot be clearly classified into metals and non-metals. Will chemical properties help? Let us understand the chemical properties first. When we look at the chemical properties, there are a few things that we need to look at. We will see what happens when the metals are burnt in air, when the metals react with water, and when the metals react with acids. And lastly, we will see what happens when the metals react with the solution of other metal salts. In all the four categories, we will look at how reactive the metals are. If they react easily, we say that the metals are highly reactive. If they do not react easily, we say that the metals are less reactive. Now, let us focus on the first category, when metals are burnt in air. The most important point that we need to note here is that all metals react with oxygen to form metal oxides. These metal oxides are basic in nature, but some of them can also be amphoteric. Now, what do you mean by amphoteric? The metal oxides which show acidic as well as basic behaviors are said to be amphoteric. Most metal oxides are insoluble in water, but some of them may dissolve to form alkalis. Metal oxides formation is one thing, but do all the metals show the same level of reactivity? The answer is no. All the metals show different level of reactivity with oxygen. Some of the alkaline metals such as sodium and potassium are very reactive with oxygen. They even react at room temperatures. Different metals show different level of reactivity with oxygen. Metals like aluminium, magnesium, zinc and lead also react at room temperature with oxygen, but they react a bit differently. When these metals react with oxygen, they form a thin coating of oxides on their outer surface so that the inner surface is prevented from oxidization. What about the metals that are present at the bottom of the spectrum? Yes, metals like silver and gold. Can you guess how these metals react with oxygen? They do not react with oxygen at all. They don't even react at high temperatures. So, we say that potassium and sodium are very reactive, whereas magnesium are less reactive. But only this category isn't enough for us to judge the order of reactivity of these metals. We can say that a few more reactions to judge the reactivity, so that in the next lesson we will see how the metals react with water. So, we can say that only this category isn't enough for us to judge the order of reactivity of these metals. We can see a few more reactions to judge the reactivity, so that in the next lesson we will see how the metals react with water.